Hey everyone, welcome to FabForge 5. I'm glad you're here. We design and build fun and unusual things, and we always learn something new along the way. We'll start a new project today. It's a custom-made secret knock book. It only opens when its user taps their custom secret knock. It has a lot of different aspects to it. 3D design, 3D printing, laser cutting, custom printed circuit board, electronics assembly, and some programming. It all comes together, I hope, in a really cool project to have some fun with. We'll see how it works. Stay tuned.
FabForge 5.
All right, I built a prototype of this a while ago. So here's how it works. This is a book box I bought at a hobby store. It's got our secret knock mechanism inside it, and it works like this. There we go, it just popped open. It only opens when the latch allows it to. There's a mechanism inside it that we'll talk more about in a bit. It's battery powered, Arduino microcontroller, and it works great. The problem is this box at the hobby store was a limited edition only. I could only buy a few of these and then they're just gone. I can't find them anywhere else. So we need to redesign our project to fit inside our own custom box. Also, to fit this box, it was a little bit tough. I had to make this small custom 3D printed battery holder to hold 3 AAA batteries, and it just barely fit, and it was tough to build this and make it work reliably every time. Not the best thing if you want to make a bunch of these for friends and family and for different customers. So we'll redesign it and we'll have some fun. We'll see how it works. Let's get started. Here's a look at the schematic for our secret knock book. It's pretty simple. It has a Arduino Pro Mini here, which listens for a tap or a knock with the piezo disc. It's got a small resistor here to condition the signal that comes from the disc, and then that goes into an input, an analog input on the Arduino. It just listens all the time, and when it hears a tap or a series of taps, it decodes them to see if they match the pre-saved actual knock. And if it matches, then it turns the servo here to move the latch to open the cover. It's got a small vibration motor to interact with the user in a couple of different ways, which we'll talk about. It's also got a push button switch, which allows the user to program their own custom secret knock. And then it's got a power switch here, a little slide switch. And then of course it's powered by 3 AAA batteries for 4.5 volts. So pretty simple. So let's switch over to Fusion 360 and we will start working on our printed circuit board. So here's that schematic in the electronic design version of Fusion 360, which is also known as EagleCAD. So pretty simple. In this case, we're designing a printed circuit board that just has a number of solder pads on it that will connect different parts to, the parts that we just saw in our schematic. No actual parts mount on the printed circuit board. Well, I'll explain that more as we go. But here's the schematic, and then here is the resulting printed circuit board. So the red is the top layer of the board, the blue is the bottom layer, and you can see a number of different connections. These are the connections, for example, for our push button switch, and this row of connectors is for our Arduino Pro Mini. Now the nice thing about Fusion 360, because it's totally integrated, when you design a printed circuit board in it, you can also see the actual 3D printed circuit board. And so here it is. So you can see that we've got our correct sizes, we can see where our solder pads are, our different connections. Pretty simple board, but definitely necessary for what we want to do. So now let's take a look at where we put this board in our overall design. So we'll switch over here. So here's our printed circuit board. Now it needs to fit inside a holder or a base, which looks like this. This is a 3D printed part. The printed circuit board slides right into it. And then we have our Arduino Pro Mini right here. So it solders onto the printed circuit board and fits in this little space right here. Now, one thing I did when I designed this this overall circuit is I'm only using pins on the Arduino for one row of connections. I don't need to use a second row. It actually saved me a lot of heartburn from adding a second row of connections on a printed circuit board. So the Arduino fits right in there. And then if we look at the different parts, let's see, for example, where our servo fits. So we'll use a little sub-micro hobby servo that fits right there in that space. And by the way, when you're designing something complex like this in Fusion 360, notice that this servo space, it's got a lot of little features to it, a lot of little tabs, etc. And so one great way to do that is to use the combine function. Watch my video on the combine function to see how easy it is to carve out a void in a part using the volume of another part. It's actually really simple. So we've also have a small latch arm here. That latch arm is what the servo moves and lets our book pop open. And then because we're sitting at the bottom of our little book box, we also have a guard that fits over that. Just in case someone puts something inside the box, we don't want it sliding over and getting stuck inside the servo. So that stays there as well. Let's see. That's all the main key parts of our overall box design. So let's see how things move. So first we'll go to our servo horn and let's move this joint. So you can see that's how the servo horn moves as it spins. So there's its unlocked position, there's its locked position. All right, now let's go to our latch arm. Let's see right here, animate this, and you can see that the servo horn pushes that latch arm like this. When it unlatches right there, it allows a small metal bar to pop up. All right, so now let's see how those work together. It's kind of fun in Fusion 360 to combine movement like this. So we'll say here, we'll say animate model. Now you can see how they move together. Not perfect, but you get the idea. All right, so that's our assembly. Now I also have, of course, our battery holder. Fits right there into that nice little space, and it mounts with 2 screws through these 2 holes. So overall it looks like this. Now I haven't added to this model some other parts. I've got my little vibration buzzer that fits in this space. The piezo disc fits right here, and then the push button to program it fits right in this space and solders onto these 4 tabs. And then we've got a bunch of different connections here. Our little resistor fits right across these 2 contacts, and then our servo connects to these 3 contacts. So we have some soldering space inside there. You'll see how it all fits together when I start showing you the actual parts. Now we have to have a book for this, or a box. So we'll make that out of plywood, and it looks like, let's see if I can find it like this. So here's our plywood box. So you can see exactly where the overall assembly fits, right there in the bottom or back of the box. So there's a space or notch for a power switch, a little window to see the flashing light on the Arduino, and a mounting hole to mount everything together. So that's how that fits. Now there's another nice aspect of Fusion 360 is you can do photorealistic rendering. So let's do one very quickly of how this overall assembly looks. So we'll say render. That's about right there. And then we'll just start the in-canvas render process. This will just take a few seconds. You'll see it run through a bunch of ray tracing iterations as it solves the light and appearance issues. And here's our rendering. Looks pretty good, looks pretty realistic. Gives us a sense of what the overall box will look like and how things fit. So I use photorealistic renderings all the time. I use them to upload an image to a website, to show friends or family what I'm working on, to show potential customers what the product will look like, and even to show potential investors what they might be investing in for myself or for clients. So I highly recommend photorealistic renderings. They are great. And here are a couple of renderings of our overall assembly minus the case. You can see how things look there. Pretty realistic. I do enjoy using this aspect of Fusion 360. So our next step is to 3D print our overall base here. So what we'll do is output an STL file. Our base looks like this. Fairly complex, but we can 3D print this, of course. That's the beauty of 3D printing. And so we'll just save that as an STL. And we'll open that up in our Prusa slicer and begin slicing this. And then the second step with our plywood book is to output a DXF file of each piece of this book or base. And then we'll use that DXF file for our laser cutting. That'll be the second step. We'll take a look at that as well. Here's our base in the Prusa app in the slicer. So you can see that we definitely have some overhangs where there's nothing underneath, and since a 3D printer builds from the bottom up, we need to add some supports or scaffolds to help it build that. So let's go to our print settings. We're going to say 0.3 layer height. We will change these to 0.2. I don't need a lot of horizontal shells. And then our infill, we'll say 20% is fine. I always like cubic, which is one of the nice things you can do with the Prusa slicer. We don't need a skirt or a brim, but we definitely need support material. So we'll click right there to enable that. And there we go. Let's slice this, see how it looks. There it is sliced. So we have a total of 180 layers, quite a lot. You can see how it will build itself out. Just like that. So we'll export this G-code to our 3D printer and crank up our Prusa. I output a number of DXF files for the plywood parts of our case, our book. So here's the first set of those. This is one of the side pieces. This area is the cover. And you can see here a lot of laser cuts in here to make a flexible plywood bend, which is kind of a cool thing. You'll see that in a bit. And then I want to make some kind of a pattern or design on the cover. So I'm going to cut out kind of a diamond mandala pattern here. And then it really needed some kind of design in the middle, so I used a couple of graphics programs to make that a little star. And then I've got a little engraving here for the name of the book, my little FabForge 5 logo, and my website. So this area right here that's highlighted in blue will be a score into the plywood. There won't be a cut all the way through. This area in blue will be an engrave. And then this area that's now highlighted in blue will be a cut. So you can see kind of the difference between the three of those. So we'll go ahead and cut this out on our Glowforge, and then we'll cut the other sides and ends. And here are our ends and sides in the Glowforge app. I have enough room on the remaining sheet of plywood to make 2 sets of ends and sides. So I'll just go ahead and do that instead of wasting a piece of plywood. So here you can see these are cuts and these are scores. Those 2 circles are kind of ideal target place to tap your secret knock. So I like those to be on the bottom ends. So we'll go ahead and cut these as well. We'll use some maple plywood for our laser cut wood for our case or book. And this is proof grade plywood from Glowforge. The nice thing about this is it has a backing, a paper backing on both sides you can peel off. That's important if you don't want scorch marks on your wood after you've laser cut it. When you peel off the backing, it makes a nice, clean, crisp laser cut. You might want scorch marks if you want something that looks rustic, and that's just fine, but I prefer to not have scorch marks. So we'll load our Glowforge and start the cut. last piece to peel off. Take a quick look at the scorch marks on the paper backing here. You can see if we didn't have our paper, those marks would be on our plywood, and it's even easier to see on the bottom side. That looks actually pretty terrible, but when we peel off the backing, it will look nice and crisp. So this is the one that takes a bit of time to peel off. Let's see, got some nice crisp edges here. I really like that. There's our engraving. We'll see how that looks when we peel it off. Looks pretty good. Now, this is the part that takes a bit of time.
How long is this gonna take?
Just a few minutes.
I don't have all day.
I know you're busy. That's the end result. And we'll peel off the back side. There we go, that's the back side. So here's a nice, great example of a flexible plywood hinge. And it's still got some spring to it, so the lid will spring open when the latch releases it. Let's glue it together. I use E6000. I love this stuff. It sticks to almost anything, but still stays a little bit flexible. And so if you absolutely have to, you can pull something apart, but otherwise it's permanent and it just works well. First we'll glue our ends and sides, then we'll glue them onto the cover. This is one of the benefits of designing something in 3D CAD like Fusion 360 first. It just fits. All the tabs are in the right place. And just know it will work. Wipe off the excess. Here's our book. Now, I like to clamp this closed when the glue dries. Make sure everything's connected. Yeah, that's good. I'll let the glue dry for about 30 minutes. All right, the glue is dry in our box. Looks nice. All right, we're out of time for part one, but we got a lot of the stuff done this time. We're almost there. So in part two, we'll finish up our book box. Got a few things to add to that. And then we've got our custom printed circuit board here. We'll solder our electronics onto our printed circuit board, including our Arduino Pro Mini. We'll start integrating this with the 3D printed parts we made. We'll put everything together and then we'll test it and see how it works. Hopefully it'll work as well as the prototype, but in our nice, new, beautiful plywood box. Come back and see the next one. Make sure you subscribe, ring the bell so you know when the next video is ready. And please like this video if you enjoyed it and comment on it. I would love to respond to your comments. Until I see you again, take good care of each other. See you later. Bye.